We are discussing about one of the famous audio frequency amplifier, that is RC coupled amplifier. In the RC coupled amplifier, as we discussed, we are taking the output of one stage amplifier. In order to connect to the second stage of the amplifier, we are using a resistor and a capacitor. So this amplifier is called as RC coupled amplifier. In the first stage, we are taking the input electric signal, that may be either voltage or current. This input electric signal we are giving to the base of the transistor. But the base of the transistor will not amplify this signal unless we give the 0.7 volts to the base. We are giving the voltage in the range of the microvolts. But the transistor is saying, do not give me the voltage in the microvolts, give me in the range of the 0.7 volts. Then we will say, if I have 0.7 volts range, why I prefer for the amplification? It is asking, it is setting a condition that 0.7 volts range must be there. Then we are taking the help of the voltage source. We are seeking the help of the voltage source by the concept of biasing. This is the self-bias circuit. R1, R2 is a potential divider circuit. Some voltage of VCC is appearing across this point, which is DC. And you know what is that voltage? VCC by R1 plus R2 into R1. That is the drop across this voltage, and the remaining voltage is appearing across the R2. We are interested in adding this DC signal to our AC signal or to our input signal. To add the input signal to the DC signal, we are taking the help of the capacitor. This capacitor do not allow any DC signal. This is allowing only AC signal. This is the input capacitor. This input capacitor clamps this AC to the DC. The adding of our input signal to the DC is called as clamping. Positive clamping will be done. Now the transistor checks whether the input is at the required standards or not. As the input is at required standards, it amplifies. After the amplification, the output signal is appearing at the collector. We are using the emitter resistor here in order to get the stability. The stability factor S is depending upon this RE. This RE decides whether this circuit is stable or not. Without the RE, the amplifier can amplify the signal, but there is no stability. We cannot tell when the transistor can amplify the signal or when it cannot amplify the signal. Then there is no usage of this circuit whenever we require. In order to make it amplify, whatever the criterion, whatever the circumstances, whatever may be the temperature, we are telling, take the resistor RE. This RE gives the stability to this circuit. The entire stability of this circuit depends on this resistor RE. We properly choose this RE with the calculations. Now why we are using this CE, emitter bypass capacitor? As we have already mentioned just now, the RE is deciding the stability of this circuit. Output, when we are getting the output, in the output we have both AC and DC. In the amplified output, the AC and DC portion, the DC portion can be eliminated by using this coupling capacitor. We are finally sending the AC to this transistor as a input. The AC output of first stage and the AC input to the second stage depends on the CE, the value of CE we are using here. The emitter bypass capacitor. If we do not use this emitter bypass capacitor, through this RE, AC and DC also flows. If DC flows across this RE, there is no problem to us. We allow that. We are satisfied with that. But the problem is, if the AC is flowing through this RE, then there is a drop across the output. So we are getting a very small gain. The output is not much satisfied amplified output. If we use a short circuit here, okay, instead of using the resistor, we have shorted. Now the DC and AC both flows through this short circuit. There is no stability for this circuit. Now the criterion must be only the DC should flow through the resistor, but the AC should not flow through the resistor. We require a component which allows only AC, which do not allows the DC, because the DC should flow only through the resistor RE, then only the stability comes. Then only our standards which we have taken for the stability will satisfy the proper amplification. We are taking that device capacitor. This shorts only AC signal. This provides the low reactance path to the AC signal. This do not allow the DC. So the DC flows through the RE and the AC is flowing through the capacitor CE. Why we are using this coupling capacitor CC? If we do not use this coupling capacitor CC, in the output we are having DC, that DC will be given as input to the second stage amplifier. We are not interested in DC because we are expecting the input signal which is varying in nature, that should be amplified. So the coupling capacitor we have taken has the ability to allow only the alternating waveform. This allows only the varying waveform. This will be given as input to the second stage amplifier. The another advantage of usage of C-in and CC, if we do not use the C-in, whenever we are connecting the voltage or whenever we are connecting the input signal, every voltage source or when we are taking any input, that is having some amount of resistance, because this is not ideal. This resistance which is in series, this is we are representing in series because voltage source. This resistance is combined with the R2 and the resultant resistance of R2 is changing. If the resultant resistance of R2 is changing, biasing is changing, our amplification criteria is changing. Okay. If we are not using the CC, then the collector resistance RC, the effect of the collector resistance RC will be felt, will be taken at the R1. Now the R1 is being affected by the RC. So the parallel loading effect, the loading effect of the RC is affecting the R1. So the biasing condition of the second stage amplifier is being affected. So we are not only taking the capacitor for the adding DC and to remove the DC. We are also using this capacitor in order to avoid the source resistance effect on the R2 and to avoid the loading effect of RC on the R1. This can be done by using this capacitor CC and the input capacitor Cin. The input capacitor we generally take in the 10 microfarad range. But more we are taking here 100 microfarad because we are expecting the entire AC should be short circuited here. Whatever the AC that is coming across the emitter, that must be short circuited. Then only we will get the proper amplified output. So every component we mentioned here, if we remove a single component, the proper amplification will not be observed. We are using R1 and R2 for the self bias. We are using the input capacitor in order to couple the input to the base of the transistor, in order to add the DC, in order to avoid the source resistance effect on the R2, and we are taking the RE for the stability of the amplifier and CE to provide the short circuit path for the AC. This will not touch the DC. Okay, this is the working of the RC coupled amplifier, and the output of this RC coupled amplifier depends upon the gain of each stage. If the gain of this stage is A1 and the gain of this stage is A2, and the final output is, if example input is Vin, the output of first stage is V0 is equal to A1 into V in. This is the output of first stage. What is the output of the second stage? This will be input into A2. So this is nothing but A1 into A2 into V in. So the total output is the multiplication of the gain of each stage A1 and A2. But practically, the gain of the total RC coupled amplifier will be less than the A1 and A2. Slightly it is less than an A1 and A2. Why it is slightly less than A1 and A2? That we will discuss later. This is the working of the RC coupled amplifier. We have discussed only for the two stages. If you are interested in taking the third stage, we will connect the output of this second stage amplifier as the input to the third stage. Similarly, we can construct n number of stages depending upon your requirement. A very suitable amplifier for the audio frequency amplification.